Okay, we're going to be working on a practice math test put out by HiSET. So I'm hoping this is pretty close to what's actually on the real test or the type problems that are on the real test. Now, this was put out in 2015. I think they do one each year, but they're pretty much the same from year to year. They haven't changed too much of the material that they cover on them. So we're going to go work our way through this. Now, they have some directions, which I'll go over. It says, you can't see this now. I'm going to try to get a little bit closer here, see if I can do this. There we go, much closer. Okay. This is a test of your skills in applying mathematical concepts and solving mathematical problems. Read each question carefully and decide which of the 5 alternatives best answers the question. See, it's multiple choice, which really is very helpful when you're taking the test, and you'll see why. Then mark your choice on your answer sheet. Now, this is an answer sheet. Of course, when you take the test, you're going to be taking on a computer. There is no answer sheet. You'll be marking on your computer. So a lot of these directions will not apply. One thing that's kind of interesting, it says there are relatively easy problems scattered throughout the test. Thus, do not waste time on problems that are too difficult. Go on and return to them if you have time. So that's always smart to do the easier ones that you're sure of. Wait a second. Okay, I had to close the door here with a little bit of noise coming from the other room. Okay. We're going to go on from here because the rest just talks about what to do on this paper test, but we're going to be taking a real test. So I'm going to go right to number 1. Now you'll notice, since you don't have a copy, you can pause it a lot. Pause it so you can read the problem and try it on your own. The idea really is to do as many of these as you can by yourself. And you're going to see that sometimes all the answers are already circled. That's because they gave me a copy of this test that I think that somebody had already taken and had circled answers. So I didn't want you to be influenced by the answers that they circled. So what I did is I circled them all. So hopefully you can't tell which one they circled. And I will tell you this, a lot of times they're wrong anyway. They didn't do that well in the test. So the answer that they circled is not necessarily the right answer. Sometimes it is. Okay, I'm going to take it on a copy that I can write on. Now, this is also good practice because when you take the test, you obviously cannot write on the computer. So you will have to be writing on a separate piece of paper, working the problems out. Don't think that because it's on a computer, you cannot use paper and pencil to figure it out. You're going to need paper and pencil to work on. Okay, so I'll leave you to try the first one. Put on pause, try the first one, and then I will go right at it. A picture framing shop has the sign shown below in the window. Frame sale, half off 17-inch by 24-inch frame. Okay, a customer has a 4 by 6-inch picture. If the customer wants to enlarge the photograph so that it will come as close as possible to this fitting a sale frame, how many times should the photo be? How many times larger should the photo be? So basically you have a frame. So the frame is 17 by 24. So let me just draw a picture. So they're saying once the short side is 17, bigger side is 24. And they're inches. Doesn't matter though, but they said inches. But they have a photo, a picture that's 4 by 6. So it's much smaller. It's 4 by 6. Now they're going to blow it up. They have a way of blowing it up and making it look bigger. They want to blow it up so it fits as much as it can in the frame. So let's think. How many times should you blow it up? Well, look at the short side, 4. How many times can you blow that up so it still fits in here? In other words, if you doubled it, it would go from 4 to what? 8. But you still have room. You have 17 inches. So if you double it, you get 8. If you triple it, you get another 4. You get 8, 9, 10, 11, 12. 3 times 4. How about 4 times 4? What's 4 times 4? 16. It's almost too big now. It's 16. It can't go any more. Just 4 times. Now, does that work? You got to see if it works for the length. What's 4 times 6? 24. It barely fits in this way. So if you enlarge it 4 times, this will be 16 by 24. It'll fit in. So the answer is 4. Okay? I'll put an X on it. 4. Okay, number 2. Now read that one. I'll leave it right there where you can see it. Pause it. Read it. Okay, my turn. Consider the advertisement below. Sale, paper sale, $25 per box. 5,000 sheets per box. Okay? Which of the following expressions represents the cost in dollars of 20,000 sheets of paper? Okay, do you have enough in one box for what you want? You want 20,000. How many are in a box? 5,000. So how can you figure out how many boxes you need? You need more than one box. You only got 5,000. You want 20,000. How would you figure that out? How many boxes you need? Did you figure that out? 20,000. What did you do? 20,000, and you're going to divide by 5,000. How many 5,000s are there in 20,000? If you put that in your calculator, it comes out to 4. 20 divided by 5 is 4, right? Now, you know you need 4 boxes. What do? How much does it cost for all that? Well, you want 4 boxes, and what does it say? $25 per box. So what do? You multiply by 25. And that should give you the answer. The answer, by the way, is 4 times 25 is 100. I mean, if you had to figure it out, but they didn't ask you. It says which expression. So you want the one that looks like this. Hey, the first one looks like that. How about that? No, this one says it's going to cost $5 million. Is it 5 million? 25 is, no, I'm sorry, $500,000 for paper. I'm not going to spend that one. This one says it's going to cost $4. Well, one box costs $25. That's not right. Anyway, this is the right one. 20,000, you divide by 5,000 to find out how many boxes you need, and then you multiply by $25. Going on to number 3. I'll put it where you can read it. I might need a little more light. Pause it to read it, right? Okay, now my turn. Which of the following sets of data would be best represented by a circle graph? A circle graph is a graph where they say parts. How many parts were this? How many parts were that? Usually when they're talking about the part of a whole, like it might be how much of your tax dollar goes to different things. Like for the schools, a big part of your tax dollar goes to schools. Maybe 75 cents of your tax dollars, state tax dollars, goes to your schools. So they compare what part of a dollar you spend on each one. The other thing that they often do with a circle graph is percent, where the whole thing is 100%, and then they divide it up. Okay, maybe 75% of your income goes towards paying your housing. Maybe 20% goes for food, and it adds up to 100%. Okay, which of these would be good with a circle graph? The percent of recent United States immigrants from different countries. Okay, so they could say 75. This looks like 75. That's why I keep giving that example. They might say 75% are from Mexico. 20% are from Asia, China, right? They might do it that way. Well, that sounds like you would use a pie graph, a circle graph. How about the life expectancy of various animals? Well, they would say like a gorilla is 75. But the thing is, you wouldn't use a pie graph because that doesn't have to add up to 100 or to 1. They could all be different and just, you could add up to some other number. They're not going to add up to 1 or 100. They don't go by percent. So that's not good for that. You might use a chart. A bar graph chart might tell you the life expectancy of various animals. College tuition increased over the last 5 years. 5 years for a state university. Maybe a line graph would show you that. how much the tuition went up. It's not going to be a circle graph. The percents of people living in urban and rural regions in each of the last 6 years. Well, that could be urban or rural. One of them, if it was 1 year, they might use a pie graph, but they want 6 years. You would need 6 pie graphs, so you wouldn't use that kind of graph. You'd probably use a bar graph. The number of kilowatt hours of electricity used by a household each month over a 1 year period. Okay, they're going to be comparing 12 months. I mean, I guess you could do it, but it says the number. If it was going the percent of the year bill for each month, then you might do a pie graph. But this is saying the number of kilowatt hours. Again, that might be a line graph. It might be a bar graph, something like that. So A was the best answer. The percent of recent immigrants, where it adds up to 100% of your immigrants. And it would go by country, what percent, which each country, and it has to add up to 100%. So that would have been A. Try number 4 then. I hope you can read these all. I'm pretty sure you can read them if I blow these up. Let's see. Yeah, they're very big. You can read them easy. Okay. If 6 bottles of perfect water weigh a total of 4 kilograms, what is the weight of 9 bottles? Did you figure this one out? Well, it's got to be more than 4 because 6 weigh 4. How much does 9 weigh? How many more bottles do you want? You want 3 more bottles, which is half of the 6. So if 6 weigh 4, how much do 3 weigh? If they're half of 6, you take half of 4. What's half of 4? 2. So the other 3 bottles must weigh 2 kilograms. The 6 weigh 4. 4 and 2 would be 6 kilograms. Do you see how I got that? I take the 6 is 4 kilograms, and then I want 3 more bottles, which is half. I want 2 more kilograms. So I get 4 and 2 is 6. Now, another way you can do it, one of the guys we had in our class, his way of solving these problems, he would say 6 bottles weigh 4. How much does 1 bottle weigh? So he would take 4 and he would divide it by 6 to find out how much 1 bottle weighs. Then he would do what? He'd multiply it times 9 because there's 9 bottles. He found the weight of 1 bottle and multiplied it by 9. And if you do this, you get 9 times 4 is 36. 36 divided by 6. You would do this on your calculator. You wouldn't be doing it on paper. I like to do things on paper. You can do it on your calculator. 36 divided by 6 is 6. And there we go. 6 kilograms. Okay. Here we go. Try number 5 now. Pause it and try that one. Okay, a tourist cab fare was $12.89. If she would like to give the driver a tip of 15%, approximately how much money should she give as a tip? Now, I like to figure out tips at restaurants, 15%. And I have a special way of doing it. I say, I'm going to figure out 10%, and then I'm going to do 5% more. 10% is easy. To take a tenth of a price, you just move the decimal point 1 place. You're dividing it by 10. So 10% would be $1.289. I wouldn't think of numbers like that on my head. I would say $1.30. I would round it to an easy number, a zero number. $1.30. Now 5% is half of 10%. So in my head, I would say, what's half of $1.30? 65. And then I would add them together. 195, which is about $2. If I was giving a 15% tip, I would do $2. Sometimes I just give a 20% tip. 20% is 1/5. All you do is divide by 5. Okay? Now, how else can you do this? You got a calculator. You want 15% of $12.89. 15% of $12.89. And what do I always say in class? Of usually means multiply. But what are you going to multiply $12.89? 15%. You can't multiply by percent. You multiply by the decimal. 15% is 0.15. It's less than 1. 100% is 1. 15% is 0.15. You just move the decimal point 2 places, you divide by 100. 0.15 times 12.89. Well, if you figure that, it's going to come near $2. It's not going to be $2, but since you're giving an estimate, if you put this in your calculator, it comes out to, I don't know, $1.90 something, $1.80 something. Anyway, it's close to $2, so you would just pick $2 tip. Okay? The interesting thing is, you're estimating here, but since you can use a calculator, you may as well find the right answer and then estimate when you're done. Just round it off. Okay, try number 6. Okay, the floor of a 15-foot by 20-foot rectangular room. 15 by 20. I make the 20 the bigger one. So it's 15 by 20. And you're going to cover with carpet tiles that are 6 square feet. Now the problem is they're not telling you the dimensions, they're just telling you the area. We don't know how big this tile is, but it's 6 square feet, which means if you multiply the width times the length, it comes out to 6. The area is 6. So what are we going to do? Well, we're going to find out the area of the big space. To find out the area, the space on the inside on the floor that you're going to cover, you multiply the width times the height. Now, I'm not going to actually multiply them because they didn't multiply them. They're just writing the numbers. So I'm going to multiply 15 times 20. Now, I know that the area of the tile is 6. So how many of these 6s do I need to cover this 15 times 20, which, by the way, is 300, but we don't have to know that. We just leave it like that. How many of these 6s go into this? What do you do if you want to know how many 6s fill up this area 15 by 20? You divide by 6. How many 6s are in this area? And that should give you your answer. Okay, does that match that? No. That's multiplying by 6. 20 times 6? Nope, we want 20 times 15. 15 times 20. 15 times 20, that's what we got. It could be 20 times 15 because they're the same when you multiply. But we got it right there. They use a different multiplication table, but that's all right. So that's the right answer, C. If you figured this one out, it would be 300 divided by 6. You would need 50 tiles. 50 tiles to cover that all up. Okay, that's number 6. Moving along on to number 7. I'll make it where you can see it. Okay. Okay, this is a graph. This is our x-axis, our y-axis. They're two different variables. Which of the following graphs represents the relationship between variables x and y if a decrease in x is always accompanied by an increase in y within the domain shown? Okay, that sounds really hard, doesn't it? But it really isn't. What they're saying, first of all, you got to remember, this is where 0 is. So this might be 1, 2, 3, 4. The numbers are getting bigger. They said a decrease in x. That means when you go this way, when you get smaller. So as x gets smaller, look at the y. First x is here. The y is very little. Now as we get smaller, what happens to the y? It's up here. Then it's up here. The y is getting what? Bigger. As x gets smaller, as you go this way on x, the y gets bigger. So, if a decrease in x is always accompanied by an increase of y, is that what's happening? As you decrease x, is y getting bigger? Yes. So this one works. How about this one? Let's look at our x. When our x is here, y is there. When our x is here, y is there. X is here, y is there. As we get smaller with x, what happens to y? It's getting smaller also. That's not what this says. It says y increases. So this one's no good. We don't want that one. Now how about this one? As x gets smaller, look, y starts getting bigger. But over here, as x got smaller, what happened to y? It stayed the same. And they said if a decrease in y, x is always accompanied by an increase. No, for this part, you decreased x, but y stayed the same. So this one does not work either because it stayed the same. It did not get bigger. Only here it got bigger. And it said always. So we only want number 1. 1 only is the only one that worked. You see how we got that? We're just looking at x as it gets smaller. As x gets smaller, what happens to y? Y got bigger. Okay, number 8. I'll put it where you can see it. Somebody wrote this one. Okay, a company charges $8 an hour for lawn mowing. What would be the company charge for a lawn that takes 1 hour and 45 minutes to mow? Well, it's got to be more than $8, right? If it took an hour, it would be 8. But it didn't take an hour, it took an hour and 45 minutes. But it took less than 2 hours. 2 hours would be 16. So we know it's bigger than 8, but smaller than 16. So A and E are off. It's got to be D or C or E, somewhere in between. Okay. It almost took another hour. It took 45 minutes. What's 45 minutes? Do you know on a clock? 45 minutes. If you divide a clock into 4 parts, 45 minutes is 15, 30, 45, 60. 45 minutes is 3/4. That's 45 minutes up to there, pointing to the 9. That's 45 minutes, right? So, if it's $8 for a whole hour, how much is 1/4? How much do you get paid for 15 minutes? If a whole hour is $8, you want 1/4 of that. What's 1/4 of 8? 8 divided by 4? $2. So you get $2 for every 15 minutes. So you get 2, 4, $6 for that 45 minutes. How much did you get for that first hour? 8. How much for the 45 minutes? 6 more. That makes sense because you get almost another 8, but you didn't do the last 15. So you got $6 for the 45 minutes. And 8 and 6 is what? 14. Now another thing you could have done this. 1 and 45 minutes is what part of an hour? It's a fraction, 45 over 60. And if you reduce that, or if you put that in your calculator, you're going to get 0.75. So with the 1, it's 1.75. You worked 1.75 hours. You multiply that times 8. And that'll give you how much you make, because you get 8 for each hour, and you worked 1.75 hours. 1.75 times 8 is 14. So that's another way you could have done it. Number 9. In a certain apartment building, apartments can come with 2, 3, or 4 bedrooms. They can have 1 or 2 bathrooms, and they can be located on the lower, the middle, or the upper level. How many different types of apartments are possible? If any number of bedrooms, bathrooms, and locations can be combined. So what they're saying is you might have a 3-bedroom apartment with 1 bathroom up on the upper level. Or you could have a 4-bedroom apartment with 2 bathrooms down on the lower level. Or you could have 4 bedrooms with 1 bathroom on the middle level. There's all these different combinations, okay? How many different size apartments can you get? 2 or 3 or 4? That's 3 different sizes. And each one of them can have how many different bathrooms? They can have 1 or 2. So that's 2 different choices there. A 1 bathroom or a 2 bathroom. Already you have 6 possibilities. 2 bedroom with 1 bath, 2 bedroom with 2 bath, 3 bedroom with 1 bath, 3 bedroom with 2 bath, 4 bedroom with 1 bath, 4 bedroom with 2 bath. But then you could be on the lower, the middle, or the upper. That's times 3 more choices. Okay? So now, how many altogether? 3 times 2 is 6 times 3, 18 choices. You have 18 different choices of bedrooms. Okay, number 10. I'll move that a little. Try that one. Okay, here I go. A restaurant owner is planning to have a courtyard area sodded. Sodded means he's going to put grass down. Okay, The sod comes in rolls. They roll it up like a carpet. It looks like a carpet, but it's really living plants. It's grass. The sod comes in rolls that are 3 feet long, 1 foot wide. So they're like this. 3 feet long, 1 foot wide. If the courtyard measures 60 feet by 50 feet, which of the following expressions represents the number of rolls of sod needed? So imagine it's 60 feet by 50 feet like that or something. That's a bad picture. But anyway, it's like that. And how many of these rolls? Each one of them. So what you do is you figure out the area of each roll. What's the area of each roll? Well, it's 3 feet by 1 foot. It's 3 times 1. 3 times 1 is 3. So we're just going to write 3. That's the area of that, right? Now, what's the area of this space? It's 60 by 50. So you're going to take 60 by 50. That's the area of the space. It's going to be a big number. That's the area. And what are you going to do? You're going to see how many of these 3's fit into it. If you want to know how many 3's get into it, what do? You divide by 3. 60 times 50. This does not look like 60 times 50. It should be much wider. 60 times 50, and you divide it by 3 because 3 times 1 is 3. That should do it. Is that it? No. Is that it? 60 times 50 divided by 3. That looks like it. No. This is adding. We definitely don't want to add. We multiply to get the area. So this one's the right one, B. Okay, what time are we up to? 26 minutes, but I've only done 10 problems, and there's 29. So I'm going to go a little further. Here we go. Consider the equation. Oh, I'll let you read it. Hold it. Okay, consider the equation 6x plus 7 equals 3x minus 5. Which of the following possible first steps would prevent having to deal with fractions when solving the equation? Okay, you could divide by 6 to get x. We want to get x. But if I divide by 6, I'm going to have to divide 7 by 6 also. That's a fraction because 6 doesn't go into 7. I'd have to divide 3 by 6. That'll give me 1/2. That's a fraction. And this is a fraction. So we don't want to divide right away. We don't want to do this dividing. That one's out. What do we want to do? Well, we want to put the numbers on one side and the x's on the other. So I'm going to subtract 3x from 6x. And that'll give me 3x. And I'm going to subtract 7. I'm going to subtract 7 from this side. And put that there, right? I'll put that on the other side. I'll subtract 7 and I'll get that minus 5 and minus 7 is minus 12. That's a good number because it's divisible by 3. 3x, 6x minus 3x is 3. So I would end up with, if I subtract 3x from both sides, I'll end up with 3x and not 6x. And that 3x will disappear. And if I subtract 7, the 7 will go from here, but I have to subtract 7 from the minus 5 will be minus 12. Now when I divide, I'm going to get 3 into 3 is 1, 3 into 12 is 4. I don't have fractions. So I'm going to combine the 7 and the 5, and I'm going to combine the 6x and the 3x. I'm going to do both of those before I divide. So I'm going to pick 1 and 2 only. That's what I'm going to do first before I divide, so I don't have to get fractions. Okay, let's do number 12, and then maybe we'll see if we're far enough. A book states, you pause it and work on it first. Okay, a book states that the longest river in the country is about 3,700 kilometers long. The actual length of the river is most likely between what? So this is a rounded answer because it couldn't come out exactly 0, 0. And it used the word about. So it's near 3,700. Now, let's look at 3,600. If it was really 3,600, would they say it was 3,700? No. 3,700, it's a little bit of an odd number. It's got a 7. 6 is better than 7. So if it was 3,600, no, they wouldn't say 3,700. How about 3,601? No, they would say 3,600. All these numbers are closer to 3,000. How about 3,620? Could that be good? No, it's closer to 3,600. What number is closer to 3,700? 3,600 and what? 50. 3,650. It's right between 3,600 and 3,700. But we like to round up, so we would probably say 3,700 for this. Or any number bigger than that. 3,651. We would say 3,700. So 3,650, that would be the smallest. What would be the biggest number if we're going to say 3,700? How about 3,701? Well, that's good. That's close. 3,702, 3,703. How about 3,740? That's still closer to 3,700. How about 3,750? That one we might say 3,800. We might round up. So it's got to be between these two numbers. If it's between these two numbers, we would say 3,700. Where is that answer? The actual answer is most between 3,650 and 3,750. Right there, C. It's between those two. Okay? And let's see, we got 17 more to go. Okay, we're going to stop right here so that I don't make the video too long, and then we'll finish. By the way, we have 60 minutes to do the real test, but I'm explaining things. That's one of the reasons why it's taking so long, because I'm explaining. Okay, so we'll pick up on the next part, number 13. It goes up to 29, I think. I don't have it all the way up to, it said 32, but I don't have it all the way up to 32. I only have it up to 29. Anyway, yeah, we're going to stop at 29. We're stopping here right now, and we'll do the other 17 on the next video. Hopefully we can get it all done then. See you in a bit.